Hi class, today we're looking at Chapter 6, Lesson 1, Scientific Notation. So, why we need to learn this? When you're dealing with very large or very small numbers in science, it's helpful to be able to write it in a shorter form. When a written standard form or standard notation, the volume of the earth is 259 billion cubic miles. Using scientific notation, you can write it as 2.59 times 10 to the 11th power. Whenever you have this number up here, like the 11 is, that's called an exponent, okay? So this is called scientific notation, and this is called standard form. How did they get those numbers? How did they know that it was 11 places? Well, if you look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So they put a decimal point after the 2, and then after the 2 there are 11 places. That's how they came up with that number. So a number is in scientific notation if the first factor is greater than or equal to 1 and less than 10, and the second factor is a power of 10, which means it ends in a bunch of zeros. So an example, 1 times 10 to the 8th power, 1.54 times 10 to the 7th power, 9.99 times 10 to the 4th power. So multiplying a number by 10 to the n power, this n power just means that we're not sure what it is. When n is positive, moves, when n is positive, moves the decimal point n places, moves the decimal point n places to the right. That's the key. Positive equals the decimal point moves to the right. So for example, with this up here, if we did I use the highlighter when I want the pen, and I use the pen when I want the highlighter. 10 times 10 to the 8th power, right? So we have a 1. And then we're going to move the decimal point. So the decimal point technically is right here. We're going to move it 8 places. 1, 2, 3, 4, 5, 6, 7, 8. So that means that it would move this direction 8 places. So this one turns into 100 million. Okay, so the temperature at the sun's core is about 1.55 times 10 to the 7th power degrees Celsius. Write that in standard form. So we have 1, and right now we have 0.55, and then times 10 to the 7th power, so that means we're going to move the decimal point to the right 7 places. So 1, 2, 3, 4, 5, 6, 7. Add in our zeros. Means it's here. 1, 2, 3, comma, 1, 2, 3, comma. So our answer is 150. Ooh, no. 15,500,000 degrees Celsius. Okay, you go ahead and try this next one. Write 7.66 times 10 to the 6th power kilometers squared, the area of Australia in standard form. Press pause, come back to me when you're done. You should have got 7,660,000 kilometers squared. Okay, so write in scientific notation. Now we're going to look at going the other direction. So we have a supercomputer. A supercomputer can perform, eek, I don't even know if I can say this, 135,300,000,000,000 operations per second. Whoa! Write this quantity in scientific notation. So our decimal point currently is right here, and we need it to move the other direction. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're going to call this 1.353 times 10 to the 14th power. Okay, so that is the scientific notation. This is called standard form. This is called scientific notation. Okay, here's one for you to try. Write 3,476,000 meters, the moon's diameter, in scientific notation. Press pause, come back to me when you're done. Okay, so you should have got 3.476 times 10 to the 6th power meters. Okay, if you did, good job. If not, no big deal. Now you know. Okay, so now scientific notation with negative numbers. So numbers in scientific notation can have negative exponents. Multiply a number by 10 to the n. When n is negative, the decimal point moves to the left. So right when we were doing positives, it was moving to the right. With negatives, it's going to be moving to the left. So if we have this number, 1.23 times 10 to the negative 2, the negative squared power, we're going to move the decimal point 2 places. 1, 2. So we're going to have to add zeros. So that means this equals 0.0123. Okay, so it's just moving the decimal point to the left. Okay, see if you can do this one on your own. Come back to me when you are done. You should have got 0.00025. I think this was supposed to be inches. Okay, so numbers less than 1. Write the quantity 0.000076 in scientific notation. So we're doing exactly the opposite. So this is going to go over 1, 2, 3, 4, 5, 6 places. So then we have 7.6 times 10 to the negative 6th power. Okay. So now you try it. Write 0.000035 in scientific notation. Come back to me when you're done. Okay, you should have got 3.5 times 10 to the negative 6th power. Okay, so let's just look at our understanding. So, a number is a scientific notation if the first factor is greater than or equal to 1 and less than 10. Number 2, reasoning. Explain why 1.55 times 10 to the 6th power does not have 6 zeros when it's written in standard form. Well, we move the decimal point 6 places, so therefore there's only going to be 4 zeros because the 5 and the 5 also count within that 6. Number sense. Is 8 times 10 to the negative 5th power greater than or less than 0? Explain. So it's greater than 0 because the number remains positive even though it's a decimal point. So this is written 8 and it goes over 1, 2, 3, 4, 5. So it would be 0.00008. Right? It's not a negative number. Just because this is a negative, that just means that it's a decimal point. It does not mean that the number is negative. Therefore, it is greater than 0. When 123.4 and 654.321 are written in scientific notation, will the exponent of 10 be the same? Explain. Yes, the decimal point to each number needs to be moved 2 places to the left. So, if we're going to move this 1, 2, 1, 2, so the 10 is going to be the same. It would be 1.234, and that would be times 10 to the 2nd power. And that one's going to be the same, but it's just 6.54321 times 10 to the 2nd power. So that's why they're the same. So your homework for tonight is page 180, number 5 through 25 odd. Happy homeworking!